Hello guys, this is Sanjay Rathi. Welcome to Daily Ka Funda series. Today's topic is series resonance from network. And as you know, this is a very important topic for all competitive exams, especially for GATE, engineering services, HPCL, ISRO. Okay, so within 10 minutes you will get detail about this series resonance. So stay tuned with us and subscribe our channel. Now guys, that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam that is conducted by UPSC, and these are my results: AIR 16 in ESE 2005, AIR 21 in ESE 2008, and I have trained more than 1 lakh students through offline classes and online classes. To use my experience and get the command over concept, don't try to mug up. Okay, then guys, what is the resonance? What is the resonance condition? So means when we are applying the voltage, because of that there is a current through the circuit. Now if current and voltage are in same phase, then we are saying that that particular circuit is in resonance, right? And we want, for resonance, two reactive elements is required minimum. That is what? One capacitor and what? One inductor. So देखिए, resonance is a condition in an RLC circuit in which the capacitive and inductive reactances are equal in magnitude and thereby resulting in purely resistive impedance. What are the applications useful for constructing the filters? Right. So in analog we are dealing with what? Filters, like what? Low pass filter, band pass filter, high pass filter, and so on. So this resonance we are using there, and selecting the desired station in radio and what? TV receivers. So these are the applications. So we are getting applications in case of what? Analog and so on. So that is the resonance. Now when we are talking about the resonance frequency, so as you know, when we are saying that resonance is what? ZL is equal to what? ZC, that magnitude are same, then we are saying that particular circuit is under resonance. I am going to explain all these things. So what is the impedance? This is the impedance because of the inductor is given by omega L, and impedance because of the capacitor is given by 1 by omega C. So when we are solving this, you will get the resonance frequency is equal to 1 by root over LC, or F naught is equal to omega naught by 2 pi. Right, omega naught by 2 pi. That is in hertz and that is in radian per second. Now guys, watch this diagram. This is a series RLC circuit. Series RLC circuit. This is R, this is L, and this is what? C. That impedance is given by j omega L. That impedance is given by 1 by j omega C. That is 1 by SC. And we are here applying the voltage Vm. Now I am going to explain each and everything, and finally I am going to explain this diagram. So watch this. Then first of all, in series resonance circuit, this is R, this is L, and this is capacitor. And here we have applied the voltage. Let this phase is 0 degree. So there is a phasor notation. This is R, this is L, and this is what? C. So what is the total impedance? That is given by R plus j omega L minus j by omega C. So what is the magnitude of that? Root over R square plus omega L minus 1 by omega C the whole square. Right? And what is the meaning of the resonance? When these magnitude of these impedance are equal. So when this is equal, ZL is equal to ZC, magnitude of ZL is equal to what? ZC, then this is cancel out, and when this is cancel out, what will happen? We are going to get the minimum Z. Z minimum. What is the Z minimum? R. So at resonance frequency, impedance is what? Minimum, remember, right? And this combination, because the total impedance because of this is 0, this series combination of L and C act as what? Short circuit. Act as short circuit under series resonance. This type of questions we are getting. Okay, and minimum impedance. Now exactly, if we are having the different frequencies, for example we are having the frequency 0. So at a 0 frequency, capacitor, what is the impedance because of the capacitor? Infinite, because it is 1 by omega C. And what is the impedance because of the inductor? 0. So what is the overall impedance? It is infinite. So if the overall impedance is infinite, means what is the current? Current is 0. Similarly, at omega is equal to infinite, what is the ZC? 0. What is the ZL? Infinite. What is the overall impedance? Infinite. Again there, what is the current? 0. Now at omega equal to 0, current is 0. At omega equal to infinite, current is 0. Now in between, what will happen? First of all, when we are increasing the omega, then current will increase and it will reach to maximum. When it will reach to maximum? Exactly at resonance frequency. And what is the resonance frequency? 1 by root over LC. So at this point, this magnitude are equal. And what is the impedance? Minimum. Impedance is minimum, and that's why at this point current is maximum. And because of that, we are getting this type of curve. We are getting this type of curve. Watch this diagram carefully. This is the impedance versus frequency, like this. So this is the omega. This is what? Z, magnitude of Z. Now exactly at resonance frequency, this is minimum. What is the minimum? R. And here it will reach up to what? Infinity. Here it will reach up to what? Infinity. And that is the curve for impedance. So what is the curve for current? Curve for current is like this. At this point current is 0. Exactly at omega equal to 0, current is 0. And like this. Exactly at resonance frequency, we are getting the maximum current. Why? Because the impedance is minimum. Because the impedance is minimum. And this is the maximum current. This is the I versus omega. Okay. And that is the case. Now, if this is the maximum current I naught, then at this point, we are going to get the I naught by root 2. And then this frequencies, omega 1 and omega 2, are called cutoff frequencies. And that is called what? Bandwidth. That is called bandwidth, guys. So this is the bandwidth. This is the omega 2 and that is the omega 1. So omega 2 minus omega 1 is called what? Bandwidth. And that is the curve for current. Now, we have the relation. What are the important relation? If suppose the bandwidth is required, bandwidth is resonant frequency upon quality factor. If more will be the quality factor, less will be the bandwidth and the selectivity will be high. Right? Remember, bandwidth agar kam hai to selectivity zyada hai. So more will be the quality factor, less will be the bandwidth and selectivity will be high. So this is the omega naught by Q. What is the Q quality factor? That is given by omega naught L by R. Or that quality factor for series resonance is also given by omega naught RC. Omega naught RC. Omega naught L by R or 1 by omega naught RC. So that is the formula for the quality factor, guys. So sometimes they will ask, what is the question like this? For example, this is called lower cutoff frequency and that is called higher cutoff frequency. Then sometimes they will ask, if you have the omega naught, then what is the value of omega 2 and what is the value of omega 1? So remember, when the quality factor is very, very high, this is the bandwidth by 2. This is the bandwidth by 2. If the quality factor is very, very high, then it is a symmetrical curve. This is gap is bandwidth by 2, that gap is bandwidth by 2. So you can find the omega 2, that is higher cutoff frequency, omega h, and omega 1, that is the lower cutoff frequency, omega L. Then you can write omega 2 and omega 1. Omega 2 is equal to omega naught plus bandwidth by 2, that is the higher cutoff frequency, and omega 1 is omega naught minus bandwidth by 2. Or as you know, already I have given bandwidth is equal to omega naught by quality factor. So yeah, these all are what? Important formula for what? The series resonance. Okay. And remember guys, at series resonance, if suppose we want to plot how the current is what in phase with what? V naught. So watch this diagram. Let this is the series resonance. Okay, let this is current I. So what about the current? Current will remain same. So this is the voltage across the resistor. This is the voltage across the inductor, and this is the voltage across the capacitor. Now, what is the voltage across the inductor? That is given by j omega L into I. What is the voltage across the capacitor? Is given by minus j by omega C into I. Means in case of inductor, voltage will lead the current by 90 degree or current will lag the voltage by 90 degree, because what is the j? J means what? Angle is 90 degree. You can write like this: omega L I, angle of what? Minus 90 degree, plus 90 degree. And what is this? Omega L, right? This is the minus 90 degree. Why? Because this is the minus j. So we can, voltage will, in case of inductor, voltage will lead the current, or in case of capacitor, voltage lag behind the current. So you can draw like this, or in case of resistor, that is in same phase. Now this is the I. What about the VR? That is in same phase. What about the VL? VL will lead. What about the VC? VC will lag. This is lag the I by 90 degree. It will lead the I by 90 degree. Now, what about the magnitude of the voltage across the inductor and capacitor? Under resonance, VL, magnitude of VL and magnitude of VC are same. Right? Always remember, VL and VC will remain, guys, same. And they will cancel each other. When we are calculating the magnitude, the complete voltage will come across what? VR. Complete voltage will come across VR, and that's why when we are writing the formula, it will become Vs is equal to what? VR plus JVL, because it is 90 degree, minus what? JVC. What is the total voltage? VR plus JVL minus VC. So always remember, in series resonance, if the voltage across inductor is given, voltage across the capacitor is given, voltage across the resistor is given, if the magnitude of Vs is required, then you have to find the magnitude from this formula. What is the magnitude of Vs? Always remember, root over VR square plus VL minus VC the whole square. That is the case. Second important thing, if VL and VC both are equal, means this circuit is under resonance. They will cancel each other, and what is the Vs? The complete voltage will come across what? VR. But remember, individually VL is not 0, VC is not 0. Total combination is 0, and that's why we are saying the series combination of inductor and capacitor act as what? Short circuit. तो ये दोनों अपोजिट होंगे, एक पॉजिटिव होगा तो दूसरा क्या होगा? नेगेटिव. ये है इसका डायग्राम, राइट? ये इमेजिनरी एक्सिस हो गई और ये आपका रियल एक्सिस में हो गया. तो ये है रिप्रेजेंटेशन. दैट इज वेरी वेरी इंपॉर्टेंट. देन व्हाट इज द वैल्यू ऑफ VL? व्हाट इज द वैल्यू ऑफ VL, गाइस? तो VL is given by quality factor times of what? Vs. Similarly, VC is given by quality factor of Vs. So this is what? This is also called the magnification factor. This is also called the magnification factor, guys. This is the magnification factor Q here. So it may be possible that under resonance the magnitude of VL or magnitude of VC may be greater than what? Applied voltage. Yes, it is possible. So that's why Q is called what? Magnification factor here. So these all are the important points regarding the series resonance. Now I am giving you some points, so please go through it. If you want the PDF of this, then join my Telegram channel, that is Electronics by Sanjay Rathi. So these are the important points already I have discussed, and these are the important formula already I have given. What is the VL? That is the Q times of maximum value of the input voltage. VC, Q times of maximum value of the voltage under resonance. Both are equal. Okay, and now this is time for some assignments. Now guys, try to solve this question. This similar question in HPCL exam. Which one of the following statement is not correct for the circuit shown below at resonant frequency? Current is maximum. Yes. Under resonance, current is maximum. Equivalent impedance is real. Yes. Z is equal to what? R. That is also correct. The inductive and capacitive reactance are equal in magnitude. Yes. ZL is equal to ZC. That is also correct. The quality factor equals to 1 by R root over L by C. C by L. So what is the quality factor here? quality factor is equal to, remember, omega naught L by R. What is the omega naught? You can write 1 by root over LC. Suppose I am going to write 1 by root over LC into L by R. So guys, what is the formula here? Quality factor is equal to 1 by R root over L by C. You will get this like quality factor. Please check. So what is given here? The equal 1 by R root over C by L, and we are getting what? L by C. We are getting L by C, means that is wrong. That is wrong. So this is correct. Current is maximum at resonance, equivalent impedance is real, and so on. So this type of questions, quickly you have to give the answer for this. Okay, so that is important topic. Now that is my number. You can message me at this number, and if you want to give any suggestion, and if you want to discuss this type of questions, then please. And that is the assignment for you. Try to solve this question. Okay then guys, this is my Telegram channel where I will upload the PDF, and in daily ka dose we will discuss previous year question related to what? Series resonance. So stay tuned with us, subscribe our channel, and thank you for attending this session guys. Have a nice day.